Well, what we see are 7 jets coming out of these objects, more than 7 actually, after it passed close to the sun on October 29th. And we can see that some of these jets are pointed towards the sun, and they penetrate over 1 million kilometers through the solar wind.
On November 15th, deep in the mountains of Hebei province, a signal returned from the Chang'e Deep Space Radar System that stunned China's top astronomers. A dense mass inside 3I Atlas, the now infamous interstellar visitor, appeared to be moving on its own, not rotating in unison with the outer crust, not following a gravitational tumble, but rotating slowly, deliberately, along a completely different internal axis. Within 24 hours, the raw data made its way to Harvard's A.V. Loeb, who issued a sharp statement.
Technological object, maybe the jets are coming out of thrusters, in which case technological thrusters can reach much higher speeds for the gas that comes out of them.
We're not looking at natural motion. This looks like internal mechanics. That comment, coming from one of the most scrutinized astrophysicists alive, sent shockwaves through the global scientific community. Because if the core of an interstellar object is decoupled from its shell, and that core is rotating with measurable mass and timing stability, then we're no longer dealing with a random rock from another star system. We're possibly looking at something designed to fly, to self-correct, or even to survive impact. What follows is a step-by-step walkthrough of what China's data really shows, how it compares to the Oumuamua mystery, what thermal and material scans now suggest, and why this internal movement could be the most important signal ever captured from an object that shouldn't exist. This isn't about glowing jets, strange tails, or passing light. This is about the hidden silence inside Atlas, the quiet, rotating core that breaks every model we use to explain the cosmos. Let's begin with the first signal China received. At precisely 04:12 Beijing time, China's Chang'e Deep Space Radar Network completed a multi-angle ping sweep of 3I Atlas. The facility, originally designed to track long-range asteroid threats and lunar deflection trajectories, had reoriented its full power toward Atlas for the first time in weeks. What they received was not just an ordinary return signal from a space rock, it was double-layered, and it didn't make sense.
Detected what may be the first microwave whisper from an interstellar object. The astronomers wanted answers from interstellar darkness. What they caught was beyond expectation.
The first echo came back as expected. A clean surface return consistent with a large irregular comet-like body. But milliseconds later, a second echo arrived, slightly delayed, but clearly distinct. This second signature appeared deeper, fainter, but precisely localized, and moving. Initial thoughts pointed toward instrumentation error or echo scatter, but follow-up pings returned the exact same signal structure. A dense mass, almost like a separate body, was embedded within Atlas, rotating on its own, completely decoupled from the outer shell. The crust and this inner mass did not spin together. Instead, they drifted. Radar depth mapping traced the motion over a 48-hour window. The outer crust of Atlas completed nearly 3 full rotations, consistent with previous measurements of roughly 16.1 hours per rotation. But the core? It barely moved once, and its rotational axis was tilted several degrees, off-center. Chinese astrophysicist Dr. Ling Zhao noted this with alarm. It's behaving like a nested object, one rotating body inside another, something you would never expect unless it was engineered that way. No comet in recorded history has ever exhibited internal differential motion like this. It raised immediate questions. Was this a pocket of dense material somehow rolling free inside? Or was it something more structured? The radar signatures suggest coherence, not chaos, a sign that whatever is inside Atlas isn't tumbling, it's turning, with intention. To validate the strange echo, China deployed a process called rotational echo isolation. Using the baseline rotational model of Atlas's surface, scientists filtered the outer noise and focused on the lagging internal signature. What emerged was both clearer and stranger. The outer shell of Atlas showed rhythmic consistency. Every ridge, protrusion, and thermal void tracked as expected over a 16.1-hour cycle. But inside, the radar discovered a lopsided object turning once every 31 hours. That's nearly half speed, and tilted at an 11-degree angle from the outer spin axis. It wasn't just the speed that caught attention, it was the stability. In nature, internal fragments or liquid cores wobble or oscillate randomly inside fractured comets. But this signal showed fixed precession, a smooth rhythmic tilt in the core's motion, like a controlled gyroscope. China's lab at Purple Mountain Observatory confirmed the behavior across multiple readings. No matter where Atlas was scanned, from polar orbit angles to solar opposition, the inner mass turned independently. This forced the scientific team to confront an uncomfortable conclusion. The interior of Atlas may not be natural at all. Avi Loeb summarized it plainly.
Given that speed, we can tell that there is a lot of mass carried by these jets so that they can penetrate through the solar wind, about 5 billion tons.
We're not talking about fragmentation or tumbling. This is shell core decoupling. Something inside is operating on a different schedule. In nature, that doesn't happen. The internal motion, especially with such clean angular displacement, suggests that the core could be mechanical, or at least operating on principles of artificial mass management, which raises an urgent follow-up. If the core is moving on its own, what is it made of?
Technological object, maybe the jets are coming out of thrusters, in which case technological thrusters can reach much higher speeds.
The discovery of a moving core inside 3I Atlas has drawn immediate comparisons to the case of Oumuamua, the first known interstellar object to pass through our solar system back in 2017. At the TIM, Oumuamua's bizarre shape, lack of a comet tail, and unexplained acceleration sparked years of debate. But one thing was certain, it didn't behave like any asteroid or comet we'd ever seen. Now, with Atlas, the similarities are growing, but so are the differences. Unlike Oumuamua, which left us with just a brief window of observation, 3I Atlas has offered weeks of high-resolution tracking, and now, thanks to China's deep space radar scans, we're seeing something Oumuamua never revealed: internal structure. Where Oumuamua tumbled chaotically and accelerated without visible thrust, Atlas maintains consistent orientation, with a rotating core hidden within a stabilized shell. This isn't the behavior of a simple rock, it's the hallmark of a system with mass control, the ability to shift internal weight to manage trajectory or balance. Avi Loeb was among the few who speculated Oumuamua might have been artificial, perhaps a defunct probe or solar sail, but he now says Atlas presents a much clearer anomaly. With Oumuamua, we had to speculate from a distance. With Atlas, we're measuring from within. The rotating core gives us a blueprint that Oumuamua only hinted at. This puts Atlas in a class of its own, not just an interstellar traveller, but one potentially equipped with internal systems. Whether for stability, propulsion, or something more, remains to be seen. And if the internal movement is mechanical, then we may finally have proof that Oumuamua wasn't a refluke. It was a prelude. Once China isolated Atlas's internal echo, the next step was determining its density. Using the radar's phase shift return, scientists estimated how deeply the signal penetrated and how much mass it reflected. The results were not subtle, they were shocking. The outer crust of Atlas appeared porous, consistent with carbon-rich cometary material. But the inner core produced a reflection pattern similar to dense alloy, nearly 3 times heavier than what should exist inside an icy interstellar body. Digitally modelling the mass distribution revealed an even stranger truth. The shell and the core do not behave like one object. They behave like a heavy internal weight suspended inside a lighter outer casing. It is the exact mass layout engineers use in long-duration spacecraft to maintain stability. But the most disturbing part was not the density, it was the inertia. When Atlas passed through solar wind variations, the crust reacted, rotating slightly faster or slower in predictable ways. But the core did not. It maintained its slower rotation regardless of external forces. This indicated inertial isolation, a technique used in advanced engineering to stabilize sensitive internal components. If the core were natural rock, it should have accelerated with the shell. If it were a clump of denser material, it should have rotated irregularly. But instead, it held a deliberate, stable rhythm, as if guided by something within. One simulation suggested the core was not just heavy, it was purposefully shaped. Another hinted that the shell may have been constructed around the inner mass, forming a protective exterior. Avi Loeb reviewed the density models and offered a quiet, chilling comment. This is mass control. If nature built it, nature is more of an engineer than we are. But if engineering did build it, then Atlas is not a comet, it is a vessel. Within 6 hours of receiving the translated telemetry from China's Chang'e Deep Space Radar team, Avi Loeb issued a statement that stunned the academic community. In a single line, he reframed the conversation. This is not geophysics. This is mechanics. Loeb had already spent years defending controversial ideas that interstellar objects could be artificial, that civilizations might leave remnants, and that science should be open to evidence, not afraid of it. But this time, the evidence was speaking for itself. This statement came after a closed-door briefing with a panel of international researchers. Loeb had reviewed the 3D reconstructions of Atlas's core motion, the timing differentials between the inner mass and shell, and the inertia modelling that showed mass resistance inconsistent with rock. He didn't speculate. He didn't use the word alien, but he did point out something that changed everything. We have two bodies in one. One is rotating faster, made of porous carbon. The other is slower, denser, and reacts differently to external torque. That suggests decoupled systems, which implies intentionality. The key word was intentionality. No one expects that from comets. Loeb further emphasized that even if the object is natural, the behavior of the core presents a physics puzzle that no current model can solve. And if it's artificial, then it marks the first known evidence of an object built to navigate between stars. The media ran with it. Headlines screamed about comet engines and alien cores. But Loeb remained calm. He didn't call Atlas a probe, he simply asked, why is the interior rotating separately, and why is it so dense? The question still hangs over every observatory watching Atlas now. Because no one, not NASA, not ESA, not China, has a better answer. In space, structure equals behavior, and behavior reveals origin. When an object spins, how its parts move tells scientists everything about its formation, its composition, and even its potential age. So when Atlas showed internal rotation separate from its shell, physicists immediately understood the gravity of the situation. In natural objects, comets, asteroids, planetary debris, internal motion is dictated by structural integrity. If a core is solid, it moves with the shell. If a body is fractured, the interior tumbles chaotically. There is no known precedent for a core that rotates cleanly on its own axis inside a sealed object, unless that object is engineered. This is why the internal movement matters so much. If the core is moving separately, it must either be lubricated by fluid, impossible at Atlas's temperatures, suspended in vacuum, which requires artificial containment, or controlled by mass distribution. In all three cases, this isn't just a random event. It's a mechanism. Engineers use similar principles in spacecraft, called inertial mass systems. These systems allow internal rotors to adjust orientation without external thrust. It's how satellites maintain balance without burning fuel. If Atlas has something similar, it's no longer a comet, it's a vehicle. But even if we ignore the artificial theory, the physics still break. No known natural object maintains this level of internal angular separation without catastrophic breakup. The force required to hold that internal mass in place, especially through solar tides and gravitational torque, suggests either an advanced material or something inside compensating dynamically. So the question shifts. Is this the product of physics we don't understand yet? Or are we seeing physics that was designed to work this way? The internal rotation is not just a curiosity, it's a potential signature of purpose.